Hi, so today I'm going to talk about a project which I built a couple of months ago. It's a web crawler. So let's start with it. So here is the GitHub repository, you can see, and the link is provided in the description below. So first of all, what is a crawler? Web crawler, sometimes is called a spider, is an internet bot that systematically browses the World Wide Web, typically for the purpose of web indexing, web spidering. Web search engines and some other sites use web crawling or spidering software to update their web content or indices of other sites' web content. Web crawlers copy pages for processing by search engine which indexes the downloaded pages so that users can search more efficiently. So what it will do is, if you give it a link, suppose this one, okay, it will do something like this. We can use the wget module. Collect the HTML format that is kept in the web, and it will collect the links found here. So how it is implemented I will tell in the explanation part when I will explain the program. So the first thing is, what is this crawler used for? It is used for Google's PageRank algorithm. So what is PageRank algorithm? It is an algorithm used by Google search to rank website in their search engine's result. So first, when Yahoo was there or search engines were there, they used some different techniques. After that, what happened? So there were two guys, Sergey Brin and Larry Page, who invented this, and they invented the Google search engine. These were both from Stanford University, and here is the paper. I have provided this in the description below. You could see that. So it is the anatomy of a large-scale hypertextual web search engine. You could read this. It is used in this, and it's more complicated than what I have made. Mine is a simple version. It does breadth first search and goes through the whole web. If some encryption is not there, then it enters in the hyperlink and does the breadth first search, and it crawls through the whole of the internet as much as possible. So let's start seeing how it works. So we need Python 3, as it is written in Python, and we need this SQLite module. DB browser would be great. Let's see. Yes. Currently installing that. Then we need this beautiful soup module that's used in Python 3, which is a great tool for scrapping HTTP based pages. So let's install this. Yep, it's installed. Then we need to install wget in Python. It's already installed, so we can start. Let's clear this out. So Let's run this. So python 3 crawl 3.py. So let's go to Wikipedia. So I'm choosing Wikipedia because it will not block me. Some site prevents scrapping by doing some bots or something, I don't know, but if I scrap them, it's illegal, so they will prevent me or block me. But we can scrap Wikipedia, so I'm doing this, giving the link, and it's collecting. If HTTPS or HTTP is found, then it collects the links. And see the speed at which it is collecting. It first finds a page, it finds all the HTTP or HTTPS, and then scraps it and stores it in the database. Okay, so I'm pausing this here, and let's say this, browse data, and it have collected about 982 links, unique links, 982 unique links in about 30 seconds most probably. So it's pretty fast. And what it does is first it collects a link. First when I have given the link, it scraps all the link that is present, it collects it and stores it here. So it first indexes them to 0. This flag, it sets it to 0. Then when it is traversed, it set the flag to 1. So if something goes wrong, it will set it to 1, so that we don't need to revisit it again. So let's see this program. So what it does is it is importing SQLite tree Python module. It is connecting to the database wiki2.sqlite. So it is making a database wiki2. It is connecting there, con.cursor. So it creates a table with 2 parameters, that is flag, it is integer, that stores 0 and 1. So it will be 0 if the link is not visited and 1 if it is visited. Then the link, and it should be unique because it connects unique links, and it's also the primary key as it is unique. Then we have imported the urllib parser, urllib, then beautiful soup and SSL. So this part, what it does, it ignores this certificate. What I have done is, first it will take an URL, it will give it to the HTML, it will read it, and it will create a soup object through HTML parser. Then it will find all the href8 tags. It will count. The count is set to 0. It is a test counter. It will get the href tags. So if link get equal to none, then continue. Here what it does is it finds the HTTPS or HTTP links, and if it found HTTP or HTTPS, it commits it, stores it into the database, into the table, and sets the flag to 0. And if 5 links are found, then it commits. Multiple of 5 are found, then it commits. What this does here is, first of all, when I have given the link, it has stored here all the links that are found. Then it will select the total link where the flag is 0. So for t-link in total link, I have taken a dummy variable. So now it will travel every link which the flag has 0 in it, and then it will this one, what it does, it converts the cursor object to number, and it will take it as a link. So here what I have done is I have used the try and except block, so that if some links are found which cannot be traversed, it doesn't blow up. So it is taking and repeating the process. So by that way we can travel every link that's found, and it will crawl through the whole of internet and store the HTTPS or HTTP links. So I have done that, and it's also in the repository. So it have collect almost 0.137 million links in 5 hours, I think. Kept it running and then slept, so it have almost found this much links. So this is all about that project. Thanks for watching, and special thanks to Dr. Chuck from Coursera for teaching such a wonderful course, which have made me possible to make this project. Thanks a lot.